Hello everyone, welcome to the new series. In this series, we will build a working RAG solution using AWS and open source models. So let's go. So this is the content outline. We will first go through the architecture that we will be building in this tutorial. We will then see the prerequisite required to complete this hands-on session. We'll understand the infrastructure as a code, which is basically Terraform scripts. We'll then deploy the infrastructure using the Terraform. So most of the infrastructure has been automated. There are certain steps which are manual, which can be automated, but I have not done them. So next is we'll apply the manual changes. So after we deploy the infrastructure, there are certain changes that has to go through manually. So we'll do them. Then I'll showcase how we will actually ingest the knowledge and how do we test the solution. And then I'll show you guys the observability metrics that I'm capturing for this hands-on. And once everything is done, we'll destroy the resources to save our cost. So let's now have a look into the architecture. So the first half, the top half, is basically a data pipeline where we will be ingesting the data into the OpenSearch, which is a vector database. And the bottom half is where we will be querying the database and fetching the response from LLM. So from top, I have created a bucket, staging area bucket. So there we will initially put our documents. So those documents then will be scanned by Lambda, and where it will check for if the document has any PI or any secret stored in them. If it is good, then that will be sent to the knowledge source, the rightmost bucket you can see. If there are anything which there in the document, then those documents will be rejected, and that will be sent to rejected document. So all these so whether they are rejected or processed, those will be notified to us through the SNS service. So you can see a notification service over there. So the second Lambda function we have is for knowledge ingestion. So once the documents are validated and sent to the knowledge source bucket, our ingest knowledge Lambda function, it will pick those documents and it will store them into the vector database. So as you know that for this framework we need to store the content as a chunks, and then we need to generate the vectors and store them into the vector database. So that is about the knowledge ingestion. In the bottom half, we will then we will simulate the LLM execution. So instead of using an Bedrock agent or any other agent, I'm using a Lambda agent, which is nothing but an orchestration service. So when a user will provide a query to Lambda agent, it will first check with the Bedrock guardrail for any harmful content, and if the user query has any harmful content, that will be blocked and will not be sent further. If the content is fine, it will then generate the embedding using the embedding model. So I'm using Nomic embed text model for this one. So that embedding will be generated, and then that embedding will be searched in the vector database, and based on the response or matching content we receive from the vector database, which is nothing but the context, the user raw query and the context will be combined, and a prompt will be created. That prompt will go to our LLM, which is running on our EC2 instance. So we are using LLaMA 3 LLM model. So that query will go to the model, and model will generate the response, and it will send back to our Lambda agent, and then our Lambda agent will send the response back to our user. Okay. And for observability, you can see I have integrated CloudWatch, where we will capture metrics for this execution of Lambda and some other metrics related to the LLM. Okay. So now in this solution, just remember that I have not created any user interface as such. So we will just simulate this from using the Postman, and rest we will execute using Terraform and through the console. So let's build this, and let's learn something new.